Okay, notes for Monday, independence and dependence. These notes go on page 21. On top of page 21, copy down your content objective and also your vocabulary. Your content objective is, we will identify independent and dependent variables and values when given multiple representations of real-world scenarios. Your vocabulary is independent and dependent. So we have a bunch of different names for X and Y. What I'm going to do is I'm going to list a few of them, and then I want you to fill in their opposites. X, we know, is always going to be our input. It's also our domain. So you know what those opposites are, or what those pairs would be for the Y variable. But then we also have independent for X and dependent for Y. Now Y also has another one, f of X. So we're going to be talking a lot about functions. So really what the f stands for is, you're saying a function of X. Let's look at example 1. An employee who works longer hours will receive a larger amount on their paycheck. That just makes sense, but what we need to do is rewrite it with this dependent relationship spelled out. So I need to figure out the blank depends on the blank. So what goes in those blanks? This is what I'm thinking. I'm thinking that as a worker, I know that the more hours I work, the more money I'm going to get. So I'm going to say the paycheck depends on the hours I work. So in this instance, we know that the paycheck depends on the hours worked, which means that we can say that our dependent is always going to be the one that depends. So what was it that depends? It was the paycheck. So the paycheck is dependent. And then independent would be the hours worked. Example 2, same sort of thing. A box with several books weighs more than a box with just a few books. So when I look at it, I have to think, okay, what is the dependent relationship here? Well, I know that the more books that I put into the box, the heavier the box is going to be. So I'm going to say that the weight depends on the number of books. That just makes sense. So then once again, my dependent is whatever depends on something else. So that means that the weight is dependent, and the independent is the number of books. Example 3 says, a zoo charges $6 for parking and $1.75 for each child. Now, we're trying to figure out what our dependent relationship is here. So we all know that if we go someplace with our family, the amount of money that we have to spend, it depends on however many people we bring. So what we can write down here is the total cost depends on the number of children. Sorry that I'm running out of space there. So then when we write that down again, we know dependent always comes from whatever is depending on something else. So the dependent variable in this case is our total cost. And our independent is the number of children. Okay, Now what I need to do is I need to write a function for this scenario and find the values when x equals 4 and x equals 10. So we know f of x, what we learned earlier today, is that f of x is just another name for y, and in this case our y variable is going to be our total cost. So let's start by figuring out how much our total cost is going to be in this scenario. We know that our total cost is going to be made up of a couple things. First thing we have to include is our parking. So we're going to have $6. $6 to park. But then we're going to have to add something else. We're going to have to add $1.75 for each child. So I'm going to say plus 1.75 for each child. And that's going to be x. And x, just like we learned, is another name for independent. So we have our number of children. So now I can go about solving this for the two different variables. I can do f of 4. We know that that's going to mean 6 plus 1.75 times 4. Well, 1.75 times 4 actually equals, what's that, $7? So I know this is going to be 6 plus 7, which if we add that all together, I get a total of $13. Not bad to go to the zoo. So that's one of my answers. I know that when x is 4, y is 13. Then I need to figure out again. So I'm going to figure it out with f of 10. So same sort of thing. I'm going to say it equals 6. But this time, instead of a 4 in the parentheses, I'm going to have 10. 1.75 times 10 is going to be $17.50. So I have 6 plus 17.5. Add those two together, and I know that when 10 children go to the zoo, we're going to have to pay $23.50. I want to know who's driving the car. Okay, example 4. A limo service charges $90 for each hour. We know that the longer you're in a limo, the more money you're going to have to spend. So that means that the total cost depends on the number of hours. Number of hours. So I know I can take my dependent from whatever it depends on, so the total cost depends on the independent variable, which is our number of hours. So now we need to write a function and evaluate for 7.5 hours. Okay, our function, it should start with f of x. And we know that this limo service charges $90 every hour. F of x is our total cost. X is our number of hours. There were no extra fees built in. There's no down payment. There's no gas charge or anything. So all we have to worry about is 90x. So now I just go back to work by plugging in my values. So f of 7.5 equals 90. And then instead of x, 7.5. When I multiply that out, I end up finding out that 90 times 7.5 equals $675. So that means that if you were going to rent this limo for 7.5 hours, you should plan on spending $675. Okay, that's it. Now go back and determine if each example is continuous or discrete. Example 1, example 2, example 3, and example 4. No more for today, but we do have a test on Wednesday, 9/11. Study how to work the problems, not just the answers to the problems. You need to know the process. You need to know the process.